Good afternoon, students. In the last lecture, we already discussed how the lacing action will take place and how laser beam will be formed. So we have just revised that. For the lacing action, we already seen that there is a simple process will be occur. There is a basic one of the state is called as ground state, and second one will be excited state. So initially, the all charged particles are to be lying in the ground state, and when we have to provide the energy to the charged particle by radiation of photons, say, on this charged particle, what happen? The inelastic collision in between photon and this charged particle will take place, and because of that, the energy of this photon, we know it very well, each photon having the energy h mu, that will be given to this charged particle, and that charged particle energy is going to be increases, and they are going to be excited and reach to the excited state, and it will remain in the excited state up to 10 raised to minus 8 second to 10 raised to minus 10 second. After this short period, they undergo de-excitation and they are reaching to the ground state again. So while they are reaching to the ground state, that is the de-excitation will take place. What are the energy will be stored within that? That energy will comes out in the form of radiations, that is say emissions, that is nothing but your laser beam. So in this way, lacing action will take place. So here, for this lacing action, some basic process will be carried out. Basic process will be occur here. First of them is absorption, and second important process is called as a emission. So you already seen that absorption is take place. It means that while the collision between photon and this charged particle will take place, at that time energy of this photon is absorbed by this charged particle. So we have to say that absorption will be take place. So after absorption, the energy of this charged particle which is lying in the ground state, that energy is going to be increases, and they are reaching to the higher excited state. And at this higher excited state, we know very well they are remain up to very short period, that is say 10 raised to minus 8 second to 10 raised to minus 10 second. They again undergo the de-excitation. That means emission of the charged particles, emission of the laser beam is occurring here. So here basically two type of emission will be formed. One of them is a spontaneous emission, and second will be stimulated emission. So what is spontaneous emission? We know very well in lacing action, the charged particle is entered from ground state to the excited state, and they undergoes de-excitation. While de-excitation is occurring here, no external energy is there required, and because of that, that type of the emission is nothing but spontaneous emission. That means no external energy is to be provided to that charged particle which is to be reaching to the excited state to force to them for the de-excitation. No energy, external energy is to be required there, and that type of the emission is called as your spontaneous emission. Then what is stimulated emission? While discussing about the stimulated emission, we have to just discuss what is meant by metastable state. We have to see this is ground state, this is excited state, and in between that there is one of the state that is called metastable state. What is metastable state? As soon as the charged particle from the ground state is excited to the excited state, and after de-excitation, instead of going to the ground state, that charged particle reaching to the one of the middle state, and in that state that charged particle is remain up to 10 raised to minus 3 second. That is so much period which is to be sufficient for providing the stimulation. So here, after reaching that charged particle to the metastable state, if you are not provide the external energy to that charged particle, they are remain in metastable state for long period of time. But For getting the lacing action, it is necessary that charged particle which is at the metastable state, they must undergo the de-excitation. And for the purpose of that, we have to again provide the energy which is to be incident on this charged particle which is lying in the metastable state, again which is in the form of photon. So when photon is to be incident on this charged particle, that charged particle undergoes the de-excitation and again reaching to the ground state, and that cycle is going to be repeated. And we may say that as here stimulation is to be given to that charged particle which is lying to the metastable state, that type of the emission is called as a stimulated emission. So basically we have to see here the three terms which is to be arises within this process. One of them is a metastable state, and second one will be population inversion, and third one will be population. So metastable state, we again repeat that thing. Metastable state is a dash state which is lying in between ground state and higher excited state. So in that state, after the charged particle is to be remain or come, after that we have to provide the stimulation, and because of that, that charged particle undergoes the stimulated emission. That is the lesser beam will be forming there because of the de-excitation. Now we have to consider what is meant by population inversion. Before going to see this population inversion, we have to just discuss what is meant by population. If suppose this is ground state and this is your excited state, so number of charged particle in the ground state, that is nothing but your population of that ground state, and number of charged particle in the excited state, that is nothing but the population of your excited state. The question is that what is my population inversion? For our simplicity, we have to say that population of ground state is N1, population of excited state will say N2, and when population of excited state is more than that of the population of ground state, then we have to say that population inversion will be achieved. Population inversion will be achieved. Remember that this population inversion condition is one of the important conditions to get the lacing action. So regarding this lacing action, again we have to discuss some important terms, that is what is meant by equilibrium condition or thermal equilibrium condition. Or simply equilibrium condition. What is equilibrium condition? If population of ground state is more than that of the excited state, that is N1 is greater than N2, we have to say that equilibrium condition will be achieved there. Then again one of the important terms we have to discuss here, the optical resonator. So what is optical resonator? The lacing action will take place within this optical resonator. So question is that how this optical resonator will be formed? Within that there is a two type of lenses is used. Here is one of the lens, here is another lens, and that total part will be consolated. This lens has reflectivity say 100%, and this has reflectivity near about 95%. So within this two laser there is active medium is to be placed. Question is that what is in by active medium? Active medium is those medium which is supporting for the lacing action. So when within this active medium, this lacing process will be occur, that means laser beam will be formed. In that situation, that laser beam will be travel from this lens to this lens, again from this to this. So within that, the laser beam will be travel, and because of the reflectivity of this lens is less than that of the 100%, some laser beam will be transmitted to this side. That means a laser will be comes out from this side, and this device which will here occur, the device which will be here seen, that is called as your optical resonator. So again, one of the important terms regarding lacing action is there. Pumping is the process by which the energy is to be provided to that charge particle, by which that particular charge particle which is to be lying in the ground state, they are going to be excited. That process is called as a pumping. There is certain type of pumping: optical pumping, chemical pumping, say discharge pumping. These types of the pumping is there. But as far as only term is considered, what is pumping? Pumping means to provide the energy to that charge particle, so what that charge particle is going to be excited state. So in different type of the laser, there is a different type of pumping schemes are there. 4-level pumping scheme, 2-level pumping scheme, 3-level pumping scheme. Like this number of pumping schemes are there, and as per that their lacing action will be formed there. And remember one thing is that whatever the type of laser, according to that the active medium within that laser will be there, and that active medium is supporting for the lacing process, and so what we have to get the laser. So we already seen in the last video that the laser has tremendous application, and that application regarding the medical purpose, then research purpose, then mechanically also it is useful, then for military purpose also, and for our convenience, that is say civilians purpose. That means even though in shop also there is useful, that means in case of also printing, laser printing is also there. So number of tremendous application is having that laser. Therefore we have to say laser is quite useful for human purpose. So we like to stop here. Thank you.